All right, so this is the second video in the supplement series for the AP Physics 1 review guide for kinematics. So if you guys haven't seen that video, I would highly recommend you check it out after watching this one. So yeah, let's just get right into this problem. So a distant planet has an acceleration due to gravity of 4 meters per second squared. So we're now on Earth, near its surface. A object is released from rest from the top of a tall cliff on the planet, and the object lands at the bottom of the cliff in 20 seconds. A second object is then thrown upward from the edge of the same cliff with a speed of 4 meters per second. The time it takes the second object to reach the bottom of the cliff is most nearly what? Alright, a lot of things going on here. Let's first draw a picture. So this is our little cliff, and we have a guy, right? He throws this straight down. So this first, rock, whatever, is in free fall, right? And it says that it reaches it in 20 seconds. So it takes 20 seconds to just freely fall off the cliff. But the second object he throws is straight upward. So there's no acceleration or velocity in the x direction. But what he did is he basically just threw this ball up and it came back down. Just straight up and back down. I can't really represent it on this 2D drawing. But yeah. So it's going to reach a max height somewhere, right? And we sort of want to find that max height. And we also want to find the time it takes to reach that max height. So this is the up and down analysis question, and I think it's quite interesting because it's multi-stepped. So the first thing we're gonna do is evaluate the up part, right? When this object goes up and reaches its max height, we want to find how long it takes. So let's write our known variables. So we know the acceleration due to gravity on this planet is negative 4 meters per second. The initial velocity was thrown, is said, with 4 meters per second. And the final velocity, we know, is going to be 0 because due to projectile motion, when you throw an object, it's for a brief moment when it reaches its apex, the velocity is 0 because it has the initial velocity, right? But due to the only force acting on it being gravity, that velocity is going to be pummeling downwards, getting slower and slower towards 0 before it becomes negative and starts falling down. So we can use this kinematics equation to find the time. So our final velocity is 0. Our initial velocity is 4. And we want to add on the acceleration due to gravity. And we can just subtract 4 on both sides. Negative 4. And divide by negative 4. And we find that the time it takes is 1 second. So for this ball, or this object, to reach its max apex height, it takes 1 second. Now we want to see, how far did it travel in that 1 second. So now we can use another equation. I'm going to switch colors for this. Let's use yellow. We can use this equation. So we can use the final velocity squared is equivalent to the initial velocity squared plus 2 times the acceleration and then times the displacement. All right. So let's just plug in the numbers. We know that the final velocity is going to be 0, right? Because it just hit its apex. 0 is square root of 0. The initial velocity, which is 4 squared, plus 2, and then the acceleration due to gravity is negative 4, and then the displacement. So that displacement is going to be the height, the max height it reached in comparison to the top of the cliff. So we're going to get 16 equals 0 here. And this is going to give us negative 8d. So now we can just subtract 16 on both sides and isolate for d. We're going to find d is equivalent to 2. So let's summarize what we know so far. we know that this height is 2 meters, and it took 1 second to reach that 2 meters. So now that we're at the top here, right, let's draw a little star. We're at the top. Now we want to find, what is that height combined with the actual height of the cliff, because they don't tell us the actual height of the cliff, but now it's accelerating downwards, and we want to find how long that takes, and then just combine that with 1 second in order to get our final answer. So the total displacement, right, because this cliff is going to have some sort of height, but then it also falls from the top, so you have to add whatever that is to 2 to get our final answer. So we want to find, I'm going to switch colors again for this. Let's use purple. We want to find the actual height of the cliff. And to do that, we want to use that first object. So let's just go back. All right, so we want to find the actual height of the cliff. Okay, so let's solve using our known variables. The acceleration due to gravity is -4 meters per second squared. We also know that the initial velocity in the y direction would be 0, and the time it took that first object was 20 seconds. And that's all we really know. So is there an equation we can use? Yes, there is. Okay, so we're going to do displacement, change in displacement of the y position, right? Because it's in free fall. It's a free fall object. And then the initial velocity times the time in the y direction. There's no initial velocity, right, in the y direction, so that is just going to give us 0. And then the second part, 1/2 times a, the acceleration, which is -4, and then the time squared, and our time is 20 seconds, so 20 squared. So that's going to give us a change in y of 800, I think -800, yeah, 800 meters, which makes sense because you're going downwards. So if we combine this with what we know here, 2 meters, this total distance that the ball is going to travel from its apex, right? Because now its velocity is negative, so now it is where it's actually be falling down, is 802 meters. So it's going to have more distance to accelerate, which is going to affect the time. So now let's just calculate that time it takes. So we can do that using this other equation. So let's just set up with 802, which would be our change in y, is equivalent. Actually, I think it should be, -802, which is VO times t. And this VO is going to be 0 because there's no velocity in the y direction. Plus 1/2 times a, acceleration t squared. The reason that the velocity, initial velocity, was 0 is because when it's at its apex, accelerating as initial velocity, and then gravity works upon it, and it reaches 0, and now it's going to the negatives. So now we have this equation, and all we have to do now is just plug in the numbers. So 1/2, we know what a is. The acceleration due to gravity is just -4. And then that time is what we're trying to find, so it's just t squared. So now we just want to isolate and find what t is. So we can multiply 2 on both sides, and then divide by -4. And to cancel out that t squared, we can just take the square root of this to give us t. And so t is equivalent to about 20.02 seconds, which is around 20 seconds, right? And so if we go back up here, we know that from here all the way down to when it collides, that takes 20 seconds. However, it wants the total distance, the total time it takes for that second object to reach the bottom of the cliff. So in the initial time to get up there was 1 second. And so 20 plus 1 is 21 seconds. And yeah, that was, not sure if that was a medium difficulty question, but yeah, I hope you guys understood.